Hi students, how is everyone doing? Welcome to our physical science class. Today we're going to discuss what is kinematic equation and how to solve kinematics problem. There are a variety of quantities associated with the motion of objects. These are displacement and distance, velocity and speed, acceleration, and time. Knowledge of each of these quantities provides descriptive information about an object's motion. The kinematic equations are a set of 5 equations that can be utilized to predict unknown information about an object's motion if other information is known. The equations can be utilized for any motion that can be described as being either a constant velocity motion or a constant acceleration motion. They can never be used over any time period during which the acceleration is changing. Each of the kinematic equations include 4 variables. If the values of 3 of the 4 variables are known, then the value of the 4th variable can be calculated. In this manner, the kinematic equations provide a useful means of predicting information about an object's motion if another information is known. Here are the kinematic equations. These equations are very important. You will use them throughout your high school, physics courses, and even in your college. What I like you to do is to write down the equation in your notebook so when you start solving kinematic problems, it would be easy for you to look at your notes. These are the variables. Kinematics is the study of description of motion using these variables. Now, you have these variables. The question is, which equation works? Here are some steps in solving kinematic problems. Step 1. Read and analyze the problem carefully. Step 2. Write down every quantity the problem gives you, like initial and final velocity or position, acceleration, time, and many more. Step 3. Write down which quantity or variable you are trying to find. Step 4. Look at your notes. Find which of the following equation will fit your problem. Step 5. Substitute the listed value to your chosen formula or equation. Step 6. Solve the problem using your chosen formula. And for the last step, don't forget to indicate the unit in your final answer. Let's try to solve these problems. Mia is waiting at a stoplight. When finally it turns green, Mia accelerated from rest at a rate of 6 meters per second squared for a time of 4.10 seconds. Determine the displacement of Mia's car during this time period. Here are the given. We have the initial velocity of 0 meters per second. How come that the initial velocity is 0? Because from the problem, Mia accelerated from rest. So rest is equivalent to 0. Time, 4.10 seconds. Acceleration, 6 meters per second squared. And we are going to find the displacement of Mia's car during this time period. After listing down the given variables in the equation, let us check the kinematic equations and find which equation is best for the problem. Upon checking the given, the best formula that we can use will be that d is equal to initial velocity times time plus 0.5 times acceleration times time squared. Now, we substitute the given quantities and variables to the formula. So we are looking for the displacement. V is equal to initial velocity. The initial velocity is 0 meter per second because Mia accelerates from rest. Rest is equivalent to 0 meter per second. The time, 4.1 or 4.10 seconds plus 0.5. 0.5 is constant. Do not remove the 0.5 from the formula because it's constant. Then, let's have the 6.0 meter per second squared, the acceleration, multiply to 4.10 squared. That's the time. So we will times 0 times 4 cancel because the answer will be 0. 0.5 times 6, it will be 3 meter per second squared. Then you will square the 4.10 seconds. It will be 16.81 seconds. Then cancel the 0 meter. Then 3.0 or 3 meter per second times 16.81 seconds. As you can see, I canceled the second squared from 3 meter per second squared and the second squared is 16.81 seconds squared because they are the same. You will cancel all the units that are the same. So we will come up with the unit for the displacement. So the unit for displacement is meter. Now, you're going to multiply 3 meter per second squared to 16.81 meter per second squared. So the answer will be 50.41 meter. The displacement of Mia's car is 50.41 meter. Second problem. An object accelerates uniformly from rest. If the acceleration was 2 meter per second squared west, what was the displacement when it reached a velocity of 27.8 meter per second? So first, let's provide the given. So the given are accelerate uniformly from rest, so initial velocity is 0. Acceleration is 2 meter per second squared. And then the final velocity is 27.8 meter per second. So we need to find the displacement when it reached the final velocity. The next step will be determine what kinematic equation will be suitable for the problem. So let us check which of the 5 equations is best for the problem. So we have acceleration, the final velocity is given, and the initial velocity. So we are looking for the value of displacement. So the best equation will be equation number 5. 2ab is equal to final velocity squared minus initial velocity squared. We have here the formula. All we need to do is to substitute the variable given and find the displacement. So let's substitute the given. So 2 times the acceleration is 2 meter per second squared times the displacement, and we are looking for the displacement, so there's no value yet, is equal to final velocity. We have 27.8 meter per second square minus 0 because the initial velocity is 0. So 2 times 2, we have 4 meter per second squared times the displacement. Displacement is the one we are looking for. So equals 772.84 meter per second. I come up with 772.84 meter per second squared because I multiplied 27.8 by itself. So 27.8 times 27.8 will have 772.84 meter per second. The next step will be we need to divide both sides with 4 meter per second squared. So we need to divide 4 meter per second squared by itself and on the other side in order to cancel this one and let the displacement be alone in the left side in order to compute the value of displacement. So 4 divided by 4, it's cancelled. 772.84 meter per second divided by 4 meter per second squared. The answer is 193.21 meter per second. Do not forget to indicate the unit of the displacement. Let us solve problem number 3. A soccer ball initially at rest rolls down a hill with an acceleration of 3.0 meter per second squared. It accelerates for 5 seconds before Melissa is able to catch it. How far did it roll? Let's write down the given. So initial velocity will be 0 because at rest. Then we have the acceleration 3.0 meter per second squared and then 5 seconds for the time. So we are looking for the distance. Let us analyze which kinematic equation suits for the problem. So we have initial velocity, we also have acceleration and time, and we are looking for the distance. So the appropriate kinematic equation is equation number 4. D is equal to initial velocity times time plus 0.5 times acceleration times time squared. Alright, so now we're going to substitute the given to the chosen formula. So V is equal to initial velocity, that is 0 meter per second, times time. Time is 5 seconds plus 0.5. 0.5 is constant. Multiply it with the acceleration 3.0 meter per second squared and then times 5 seconds squared. So 0 times 5 seconds is automatically 0. 0.5 times 3, that is 1.5 meter per second squared. And then we need to square the time. So 5 times 5 is 25 seconds squared. So now 0 plus 1.5 meter per second squared. So 1.5 meter per second squared cancelled 0. 1.5 meter per second squared times 25 seconds squared. So when we multiply it, we will have 37.5 meters. So we're going to cancel the same unit. So the same unit as the second square. So we will only have meter as the unit of distance. I hope you learned a lot from this video. Always remember, in computing kinematic problems, analyze the problem, list down the given variables, choose the best formula that suits for the problem, substitute the given variable to the formula and solve. And always be careful and don't forget to indicate the unit. Thank you for watching. See you again next time.